Similar versus congruent. Similar figures have the same shape, but not necessarily the same size. This is the symbol for similar. Congruent figures have the same shape and size, and this is a symbol for congruent. So we're going to construct a segment. In other words, we're going to copy a segment. So we're going to copy this segment. You draw the line first, where you're going to copy this segment. Then you go to the given segment, and with a string or a compass, you measure out its size. Don't change the settings. And then transfer that length to the line. So this is the copy. The copy is line segment A prime, B prime. Triangles are congruent if the three sides of one triangle are congruent to the three sides of the other triangle. The three angles of one triangle are congruent to the three angles of the triangle. Then if that's the case, you could say that the two triangles are congruent. With congruent, you have to be careful. You have to keep the order you started. So if you name this triangle ABC, that means you have to go through the same path on the other triangle. We went through one tape mark and then two tape marks. So in this triangle, we're going to have to do the same. So triangle ABC will be congruent to triangle A prime, B prime, C prime. Notice A prime to B prime went through one tape mark. B prime to C prime went through two tape marks. So we kept the order. Now, they're telling us that these two triangles are congruent. Write an appropriate symbolic congruence for the pair of congruent triangles. So these are congruent. We already know they are. To make it a little bit more obvious, bring in more information. What does this angle equal and what does this angle equal? Right here, we remember that the sum of the inside angles should add up to 180 always. Doesn't matter what the triangle is. So knowing that if this is 60 and this is 90, this should be 30. And if this is 30 and this is 90, this should be 60. Now it's a little bit more apparent that the two triangles are congruent. So now we could say, they told us they were congruent, but now it's more obvious, and now we could name them. Triangle BAC. BAC is congruent to triangle QRP. We kept the same order we started off with. We have to keep the same order of naming. This is a shortcut for congruence. So if you could demonstrate that three sides of one triangle are congruent to three sides of the other triangle, that's enough. You could stop there and conclude that two triangles are congruent. So notice this first triangle, triangle ABC, we have that 8, we have the 5. Triangle DBC, we have the 8 and the 5. We're missing one side. But since they're sharing this side counts as being congruent, and it belongs to both triangles. So we have SSS, SSS. So these two triangles, triangle ABC is congruent to triangle DBC by SSS. That's the reason, SSS. Now we're going to construct congruent angles. So here's the given angle. So what you do is trace out with a compass or a string. You could trace out this arc. It doesn't matter where you put the arc. Without changing the settings, transfer it to this segment where we're going to copy that angle. Notice this is B prime. This is the copy. Then without having changed the settings, trace out that arc. Now go back to the original angle. With a compass, measure this opening. And don't move that compass, don't change the settings, and transfer it to the angle you're copying. And you create another arc that intersects the original arc. This place where they intersect, that's where you're going to draw the line through. So angle B and angle B prime are congruent. Here's another shortcut. If you could demonstrate side, angle, side, that means the side of one is congruent to the side of the other. The angle of one is congruent to the angle of the other, and the side of one is congruent to the side of the other. Make sure the angle is between the two sides you mentioned. then you could say the two triangles are congruent. Right here, they give us some extra information to bring in angles into the picture. If you're saying that line segment AB is parallel to line segment DC, that means corresponding angles are congruent. Notice these are the parallel lines. This would be the transversal. And excuse me, they're not corresponding, they're alternate interior angles. Alternate interior angles are congruent. So now we have an angle from here equal to an angle from here. Now notice they're sharing, these two triangles are sharing a common side. So that counts for a side for both. So we have enough information to say SAS, SAS. So these two triangles, triangle ABD is congruent to triangle CDB. Reason by SAS. Notice the angle has to be between the two sides you mentioned. HL is used only for right triangles. This says that if you could demonstrate that the hypotenuse of one equals the hypotenuse of the other, and one leg of one is equal to one leg of the other, that's enough to say the two right triangles are congruent. In this case, we have that. Here's the leg being congruent to this other leg of the other triangle, and then the hypotenuse of one triangle is congruent to the hypotenuse of the other triangle. So we have the HL. So triangle ABC is congruent to triangle DEF by HL.